In this video, we will solve some conceptual problems related to double angle identities. Let's revise the identities first. We have three identities. The first one is sine of 2a is 2 sine a cosine a. Then we have the double angle formulas or identity for cosine 2a. The first format is cosine square a minus sine square a. Since we have the identity sine square a plus cosine square a equals to 1, we can write this particular identity in two other formats. We can write this thing as 2 cosine square a minus 1. We can also write this thing as 1 minus 2 sine square a. So therefore, there are three formats of cosine 2a. The first one being cosine square a minus sine square a. The second, 2 cosine square a minus 1. Third format, 1 minus 2 sine square a. And last but not the least, we have the double angle identity for tangent 2a. It's in a fraction form. The numerator is 2 tangent a and the denominator is 1 minus tan square a. So now let's get started with the first question. The first question says angle A is obtuse and sine of A is root 3 over 2. Now the first thing is the value of sine A is given as root 3 over 2. Root means the third form, or it's also known as the radical form. This is the exact value of sine that's given. That means we are not using a calculator, so these values are without using a calculator. Now, when we use a calculator, the answers are rounded off. So calculator answers are rounded off to a certain degree of accuracy. So therefore, we are using the exact value. The second thing is, since angle A is obtuse, that means it lies between 90 degree and 180 degree, and therefore it lies in the second quadrant. So now in the second quadrant, only sine is positive, which means cosine and tangent, they both will have a negative sign. So now the very first thing that we need to do is to draw a triangle. The triangle that we draw, that is for an acute angle, and the plus minus sign, the positive negative sign, will be taken care of at the very end. So now this is angle A and sine is opposite. So root 3 is the opposite value and 2 is the hypotenuse value. And since we are drawing a right angle triangle for this purpose, the base will come out by Pythagoras theorem. So base square plus height square is equals to hypotenuse square. A little bit of calculation is needed. Base square plus 3 is equals to 4. Base square is equals to 1. Therefore, the value of base is 1. Now, from this triangle, let's write down the value of cosine of A and tangent of A. Cosine of A is coming out to be 1 over 2. 1 is the adjacent, 2 is the hypotenuse. And tangent of A, if it's needed, the value is root 3 over 1. Root 3 is opposite and 1 is adjacent. Also, based upon the quadrant, the value of cosine has a negative sign. The value of tangent has a negative sign. Now let's go back to the question. What are we supposed to calculate? We are interested in sine of 2a, cosine of 2a, and sine of 4a. So now we have all these values. Let's get started with the first part. The first part is about sine of 2a. Let's write down the formula. That is 2 sine a cosine a. We will just plug in the value of sine a and cosine a and do a little bit of calculation. The value of sine a is root 3 over 2. the value of cosine A is negative half. So bit calculation is needed. The 2 and the 2 disappears, cancels off, and we are left with negative root 3 over 2. This is the value of sine of 2A. Similarly, we can evaluate cosine of 2A by any format. Let me choose the second format, which is 2 cosine square A minus 1, which is 2 multiplying with cosine A, the whole thing square minus 1. What is cosine of A? Cosine of A is negative half. So let's square negative half. And what do we have? We have 2 into positive 1/4 minus 1, which is half minus 1, which comes out to be negative half. So this is the value of cosine of 2A. Now, what is the third part being asked? So we are done with sine of 2A, cosine of 2A, and the third part is sine of 4A. In order to evaluate sine of 4A, let's first modify the formula. The original formula is sine of 2A, which is 2 sine A cosine A, and we call such formulas as double angle formula because the angle doubles. The angle A on the right, there is an angle A on the right and angle 2A on the left. That means I can write sine of 4A is 2 sine 2A cosine 2A. So therefore, let's plug in the value of sine 2A and cosine 2A. The answer for first part was sine 2A, which came out to be negative root 3 over 2. And the value of cosine 2A is negative half. So the very first thing is that these two negatives will cancel out. The 2 cancels with the 2 and we are left with root 3 over 2, a positive value. So sine of 4A is coming out to be positive. That's how these conceptual questions are done. Let's look at the second question. Given that cosine theta is negative 4 over 5 and that theta lies between 180 and 270 degrees, find the exact value of the following ratios. Step number 1 is to write down the quadrant. So we locate the quadrant based upon this range over here. Between 180 and 270 degrees is the third quadrant, and we know that in the third quadrant only tangent is positive, which means sine is negative, which means cosine is negative, and we can already see the value of cosine being negative. Now the very first thing is that we draw a triangle, a right angle triangle, to evaluate these ratios for acute angle, and the positive negative sign will be dealt with later. So this angle is theta, this is right angle, the value of cosine is 4 over 5, so the base is 4 and the hypotenuse is 5. So we can call it the base, we can call it the adjacent with respect to theta. Similarly, 5 is opposite of 90 degree, so 5 is the hypotenuse. Let's call the vertical side as the height or the opposite. Let's do a bit of calculation. 5 square is equals to 4 square plus h square. 5 square is 25, 4 square is 16, h square remains as h square. The difference between 25 and 16 is 9, that is h square. Therefore, the value of h is coming out to be 3. Now, the triangle is complete. So the value of h is 3. And now we can evaluate the value of sine. Sine of theta is 3 over 5. Tangent of theta is 3 over 4. Sine is also negative because it lies in the third quadrant. Tangent of theta is positive. So now we can go ahead and evaluate the exact value of sine of 2 theta, tan of 2 theta, sine of 3 theta based upon these three trig ratios. Let's start with sine of 2 theta. That is 2 sine theta cosine theta. That is 2 multiplying with the value of sine theta multiplying with cosine theta. The value of sine theta is negative 3/5. The value of cosine theta is negative 4/5. Very first thing, the two negatives will cancel out. 2 multiplies with 3 multiplies with 4. That comes out to be 24. And the denominator is 5 multiplying with 5. That is 25. So sine 2 theta has a positive trigonometric ratio. We now need to evaluate tangent of 2 theta, which is 2 tangent theta divided by 1 minus tan square theta. The value of tangent theta is 3/4. Let's also square it over here. Tan theta, the whole thing square, is 9/16. And we know that tan theta, the whole thing square, is usually written as tan square theta. So let's evaluate this trigonometric ratio also. That is 2 multiplying with 3/4. And I'm putting in this traditional division sign. And the denominator is 1 minus tan square theta, which is 1 minus 9/16. This is the value of tan square theta. This is 6/4 dividing with 1 minus 9/16 is 7/16. Let's do the calculation on this side. 1 minus 9/16, that is 16/16 minus 9/16, which comes out to be 7/16. So 6/4 multiplying with 16/7. Let's simplify. 4 ones are, 4 fours are. 6 into 4 is 24. So this comes out to be 24/7. This is the value of tangent of theta. And last but not the least, we are interested in evaluating sine of 3 theta. Now the question is, do we use a double angle formula for evaluating sine of 3 theta? There is no harm in trying it out. Sine of 3 theta is 2 sine 3/2 theta cosine 3/2 theta. The question is, on which basis have I written this formula? If this is A, therefore this is double of that, this is 2A. But this methodology of working it out using the double angle formula won't work because we don't have the ratios for sine of 1.5 theta, cosine of 1.5 theta. That means we have to think out of the box. So therefore sine of 3 theta is written as sine bracket 2 theta plus theta. That means we will be using the addition formula for sine A plus B. What is the addition formula of sine A plus B? It's sine A cosine B plus cosine A sine of B. So in this particular question, 2 theta will be treated as A. And theta, we will treat it as B. We know that the value of sine of theta is negative 3/5. And the value of sine of 2 theta is 24/25. So let's rewrite the formula. Sine bracket 2 theta plus theta. That is sine 2 theta, cosine 2 theta, sine theta. Let's recap. What do we have? We already calculated the value of sine 2 theta. Sine theta was already given initially. Cosine theta is also written at the top. So let's scroll up. The value of cosine of theta is what we started with. That is negative 4/5. So let's write it down also. The value of cosine theta is negative 4/5. So which is the only piece that's missing? That is cosine of 2 theta, which we can very easily evaluate. So let's first evaluate cosine of 2 theta. Let's use the formula 2 cosine square theta minus 1. That is 2 multiplying with value of cosine, the whole thing square minus 1. The value of cosine is negative 4/5. That's 2 multiplying with 16/25 minus 1, which simplifies to 32/25 minus 1. 32 over 25 minus 1 can be written as 32 over 25 minus 25 over 25, which comes out to be 7 over 25. So the value of cosine of 2 theta is 7 over 25. So now let's plug in everything over here. We have sine 2 theta, which is 24 over 25. Cosine theta, which is minus 4 over 5. Cosine 2 theta, that is 7 over 25. Sine of theta, which is minus 3 over 5. So all we need to do is to multiply 25 and 5, and that is 125, and that is 125. And when we multiply 24 into 4, that is negative 96. When we multiply 7 with negative 3, that is negative 21. So we add it up and the overall sign is negative. So 125 is in the denominator. 96, 97, that is 117. After the addition, that goes at the top. This is the value of sine of 3 theta. So what have we learned in this video? In this video, we applied the double angle formula. We took care of the quadrants to determine the signs of sine and cosine and tangent. We drew right angle triangles to evaluate the trigonometric ratios, and based upon the quadrants and the double angle formula, we evaluated the exact value, that is without using a calculator, and leaving the answer in the surd form.